What's going on, arcade nerds? You are looking at what I believe to be the world's smallest vector monitor. This was just a pointless project that I did, just a one-day project. I actually did this about 10 years ago, maybe 10 years ago. And I was on Facebook, and this was a couple years ago now, and I said, yeah, I have made one from a viewfinder tube before. And someone said, pictures or it didn't happen. You know, so, and you know, I long have lost that monitor and so on. And I don't know why, but every once in a while it was stuck in my head. Like, you know, how do I prove it, you know? So I figured I'd make this like a one-day project. And so I did it again. Well, anyways, so what this is it's a camcorder CRT, okay? And here is your camcorder deflection board and all that. Now, I had to wind my own yoke coil. The original yoke coil could not be used because the inductance is far too different between the horizontal and vertical coils, okay? But, yeah, so this was just a quick one-day project I did. Before I show you it working and how it works, let me draw up a quick schematic and show you how I did it. That way, if you ever want to do it yourself, you can do it yourself. Okay, before I write you up a little schematic, let me explain why we need this schematic. Okay, now let's picture a picture tube. Something like that. I'm not the best artist here, so bear with me. One of the tubes on the back of that picture tube is going to control your gun, okay? Now, normally on a TV set, vector monitor, whatever, there's going to be a wire coming off of that going to a resistor, and that resistor will hold this wire high. Normally it would hold this wire high. When I say high, I'm saying it would hold it at a voltage. In my situation, the voltage was 12 volts. Okay? Now, there would be yet another wire coming off of here that would ground this 12 volts to ground. Let's just make a simple switch. Okay, so here's a ground. If this switch were to be closed, it would ground this wire out. And if this wire were to be grounded out, it would turn the beam on full intensity. Okay? And the reason we have a resistor here is so this ground doesn't also ground out our 12 volts. Okay? So what I did was with this, I measured the pins all across the neck, and I found a low voltage. Okay, and once I found that low voltage, and see, you gotta have two low voltages that are going to be on the back of any CRT. One is going to be your heater, and the other is going to be your gun voltage. Okay, so I found 12 volts, and what I did was I had a wire go to a ground, and I touched that 12 volts, and that little screen lit up. So I said, okay, so that's my gun. Simple as that. You don't need to look up the pinouts. You can figure it out without looking up the pinouts. Okay, so so we needed to build a circuit that can control this. So what I did was I snipped that wire on the back of that tube. Okay, so now I know that wire. So now that wire will be floating, of course. So we need to control it. So what I did was, I have a 5 volt power supply going to this. So what I did was, we have our 5 volts. I put in a mini DC to DC converter. Okay, and you can see this DC to DC converter right here. Okay, you can pick up these DC to DC converters for about $1.50 on eBay. The one I happened to use was 15 volts. Okay, so what I did was that 15 volts is going to a potentiometer, and each side of that potentiometer is right here. This is going to ground. This is going to your positive 15 volts. Now, right here is the wiper. Now this potentiometer is acting as a voltage divider. Depending where I move this wiper, it'll either be closer to the 15 volt side or be closer to the ground. And because of that, I can select whatever voltage I want. Well, it just so happens I found out that about 10 volts is where the gun just starts to turn on. Okay, so what I did is we have that going to yet another voltage divider. Now this is going to the gun. Okay, now see, we have two pots here. One is going to be for brightness, and the other one is going to be for contrast. Now, we're going to throw an inverter here. Now, I can already see it. I can see it in my mind. Some of you guys are going to say, "Oh, Jason, you can't convert analog signals with a digital device." And I'm going to tell you, yes, you can, within reason. For example, if I were to put a transistor here, okay, well, anyways, wait, I'm going to get right back to that, but give me a second. Okay, so now if we have a positive pulse going through this inverter, it will invert it to a negative pulse. And this negative pulse will pull down the gun voltage. Now, you can't just get away with putting an inverter on any old thing, but you can get away with using an inverter on something small as this, if that makes sense. Okay, now let me go back to the analog digital thing. Okay, this is a digital device. It's only supposed to be on or off. There's no in between, right? Well, that's not really true. If I were to put a transistor here, and I were to slowly turn on the base like that, the same curve would happen between a collector emitter. Okay, so if I were to slowly energize the base, the collector emitter will slowly connect. About the same, right? Well, this will do the same thing, except there's a cutoff. So, if you were to slowly energize the base, this whole section won't be seen. It is ignored. It is lost. And then when it's fully on, it's fully on. Does that make sense? Well, it just so happens with vector arcade machines and the Vectrex and all kinds of things, the area you're really worried about for gun intensity is somewhere between 4 volt to 5 volt, which just so happens to be above the cutoff. So if I made a transistor, it could be anywhere from, let's say, 0.01 volts clear up to 5 volts. Sure, but this digital circuit is going to give me that analog buffer of 4 volt between 4 and 5 volts, which is just what we need anyways. So believe it or not, yes, you can use an inverter in an analog circuit in some situations if this is the outcome you actually want to have. It just so happens to be the outcome I want to have. But okay, so now that is done. That explains how the schematic works. Let me talk about the winding. Now, the toroid. See, the original yoke coil on this was a stainless steel sleeve with bare wires stuffed inside it. Neatly, of course. Windings. Well, I can't. It's hard to rewind something that's being held together by glue. It was just literally wires held together by glue. So I needed something to wind around. So what I did was I actually found an old computer power supply, tore it apart, And inside a computer power supply, you'll find something like this. It'll be dark. It's made out of ferrite. And that'll have windings around it. Does that make sense? This is a toroidal inductor. Okay, so what I've done is I found one about the size, a little bigger than the tube's diameter, and I made sure I could fit it over the tube, and I wound my yoke coil that way. Now, if you were to make a schematic of what a yoke coil looks like, it would be something like this. You'll see your windings here, and then over here, you'll see your windings here. And that would be for, let's say, your horizontal. Okay? Then you'd literally have another winding, and yet another winding. That could be, say, your vertical. Okay? So, how do we make this work with that? You got to know when and where to start your yoke windings, correct? So, this is how. Let me explain. Okay, let's say you have, let's redraw our toroidal. Some people also call it a donut. Okay, now, we're only going to worry about, let's say, our X. Okay, now, what you want to do is you want to start right here with your windings. And let's say we're going to go this direction around the yoke, okay? So, let's put in our imaginary windings. And we're going to stop right here. Now, we still have our wire connected to our bobbin or whatever we decide to wind this with, right? Well, loop it over, don't cut it, and continue going that same direction all around the yoke until you come out this side. Now we have two pieces of wire. This is one in the same wire. Go ahead and twist and solder that. Go ahead and twist and solder that. Now this is how I'm referring to winding a toroidal. There is different methods. Now imagine that's going to pull the beam this way or that way. Because if you think about it, if you straighten this out, you have electromagnet, and one side is going to be north, one side is going to be south. And you straighten this out, you have electromagnet, one side is going to be north, one side is going to be south. So what that's going to do is it's going to make this either be north or south or north or south in these specific points. So all you got to do is rewind this once again in this direction. So now you can have X and Y. You see what I mean? So that's all it is. It's going to pull it in any direction like that. Okay, so let's see here. What else could I say, Kelly? I have no idea. Me neither. I don't know. Let me just turn this thing. Oh, by the way. Look familiar? Yes, this is a brand new mouse trap. I was just thinking to myself, someone's going to say in a comment, oh, Arcade Jason peeled off the rat. But, no mice were harmed. No mice were harmed. But there's a toroidal I'm talking about. Here's my, ignore some of these because before I thought of that specific schematic, this is my trial and error. So some of these parts aren't even connected anymore. One of the pots. Okay, so let's hook this up and let's see what it looks like. Okay, so what I've done is I've connected those 4 wires coming from the yoke coil, and we've already made the gun work on demand when we want it to. Okay, now I've connected my 5 volts to a computer power supply, which is out of the picture there, and I've connected my 4 wires to a audio amplifier. That's all this is. But it's not just any audio amplifier. This is a high fidelity push-pull audio amplifier. This will create the least amount of distortion and noise. This is a really decent quality amplifier. You got to have a good quality linear amplifier. And anyways, what I've done is I just wired up a speaker so you can hear this. And the reason why I want you to hear this is because what I'm going to play is called oscilloscope music. There's a guy by the name of Jerobeam Fenderson. He has a YouTube channel. And it's really interesting. He does some really cool stuff with oscilloscopes. And I've mentioned him a few times in my channel before, and I just want to give him some props for doing something I think is really cool. But anyways, so what we're going to do is I'm going to go ahead and turn on my power supply. Now, I have this turned kind of low because I don't want to burn my screen, okay? I only got one shot because this was kind of a hard tube for me to find, okay? I got one shot. So anyways, I'm going to push play. Let me turn the volume up. Oh, I think I'm not... Yeah, okay, I'm connected. Okay, let me shut this off. Let me explain one more thing I think might be important for you to know. If you're going to do this yourself, if anyone wants to, I didn't tell you how many turns you need. Okay, so let's say you have your coils, like we talked about before. Let me tell you what I did, and let me tell you what I suggest doing. I did it really in a bad way, but I just did it so I worked with the parts I had. Okay, what I did was 36 turns, and I used 24 gauge wire. Okay, now yes, it will work, and it will work just fine. But this is a very power hungry yoke coil for how small it is. So this is what I suggest you do. I suggest you get a thinner wire. I know you'd have to experiment with it, but it's somewhere in the 30s gauge, a high 30s, I'd say. And I suggest you do about 200, anywhere from 200 to 275 windings. Whoops, 5, 6. Anyways, I suggest if you were to do that, get your toroid, and do 200 windings on each side, and that will allow you to use way less power. If I had an op amp, I'd show you. But anyways, I suggest doing this, and the reason why is because I had to use this humongous amplifier to make this work. If you wanted to make it more compact, you could possibly use, let's say, an NE5532.
Yep.
Is that the one? Yeah. NE5532 is a tiny little op amp, and the maximum. You got one? Let me see it. Just give me whatever you got. It'll look something like that. See that? See that little bastard right there? That could have done my deflection instead of this big ugly thing. Okay. Now the NE5532 puts out 0.06 amps of current, and I probably dumped a lot more of that in there. But 0.06 would just get you. And you know, if that's not enough, put 2. I guarantee it'll work if you run it with 2. But okay, that's about it, guys. Thanks for watching, and you know, have a good day, guys. Oh, don't forget to subscribe. Click that bell icon, and maybe you could find more of my stuff later. Have a good one.